So page 13, number 3. Let's do part A here. Okay, so whenever you see arc cosine, that's the same thing as inverse cosine. So this is an inverse function. Now, whenever you see this notation, just know that this represents theta. So in other words, this is basically saying, theta is equivalent to arc cosine of 2x or inverse cosine of 2x. And if I were to rearrange it, this is basically saying we want a scenario where cosine of theta is equal to 2x. Okay, so that's what this notation means. It's we start off, we basically want to create a scenario where cosine of theta is equal to 2x. And once we can create that scenario, then we can figure out what sine of theta is for that scenario. So cosine of theta equals 2x. Let's think about what we can do with that. Visually, if we just imagine that cosine relationship is adjacent over hypotenuse, right? So 2x over 1. I can always force a 1 in the denominator because that's equivalent, and that kind of helps us with our ratio as well. Adjacent over hypotenuse. If I can create a first quadrant ratio of that, and we're always going to do first quadrant because it's the easiest one to interpret or to evaluate. So I want to put 2x and 1 in the correct places here. So 2x can go where the adjacent side is, and my theta is always you're always drawing your triangle from the origin up to from the origin to the hypotenuse. Okay, so 2x goes here, and 1 is hypotenuse, so 1 goes here. All right, good so far. Now we need this third side as well. So what can we do if we have two sides of a right triangle? Pythagorean theorem. We know a squared plus b squared equals c squared. So if I just call this unknown, this missing side, the b value, I can say a squared plus b squared is equal to c squared. And if I can get b by itself, b squared is equal to 1 minus 4x squared. If I were to expand out that 2x squared, I'll get 4x squared. And if I take the square root to get b by itself, I get square root of 1 minus 4x squared. So now that represents my opposite side. Now that I have my scenario built from this arc cosine of 2x, I can find out what I'm really looking for, which is sine of theta. So what's sine of theta going to be? Is what? Opposite over hypotenuse. Yep. So that's it. So we get root 1 minus 4x squared over 1. If you can leave that 1 there, or we can drop the 1. So either is fine. So the strategy there is you're going to use what's inside the parentheses to draw your triangle, figure out what sides are provided based off that trig function, and then use Pythagorean theorem to find the missing side. And once you get all three sides populated, you can find the outer functions ratio. Okay. All right. What else? Yeah.
U14E.
Yeah. Yeah, this one's good one to go over. Sine of 4x is equal to 1/2. So this is the strategy that I like to use, especially also that means we can avoid having to deal with messy double angle or different identities. We're just going to rely on inverse trig. And I made a slight adjustment for this problem here. I'm only looking for x values between 0 and pi so that we can just kind of limit the number of solutions. Makes it a little bit easier. So first thing I do is let's get that 4x by itself. So I'm just going to move that sign over, call it inverse sine. Anytime you see inverse sine, just know that we're looking for theta values here. We're looking for what theta value will allow sine of theta to be equal to 1/2. Right, so this is what this means. So we know sine of theta is equal to 1/2 in that pi over 6 family in the first and second quadrant. So I'm going to say pi over 6 and 5 pi over 6. But if we look ahead to see what's going to happen, we're going to end up shrinking all these values because we're going to have to divide by 4. And what we want is after everything shrinks, we still want all the values to get all the way up to pi. So we may need more than what we see here. We may have to go past 2 pi so that when everything shrinks, our final solution will be able to extend all the way from 0 to pi. So I'm going to find coterminal angles. And the way we're going to do that, I'm going to add 2 pi. And if I want to do common denominator, I'm essentially going to be adding 12 pi over 6. So if I add 12 pi over 6, that's going to take me around to the next pi over 6, which is going to be 13 pi over 6, right? Because 1 pi over 6 plus 12 pi over 6 is 13 pi over 6. And then if I add another 2 pi to 5 pi over 6, I'm going to get 17 pi over 6. And I just wanted to go a little further. This is kind of like a guessing game because I don't know exactly how many I need. So I added another 2 pi to 13 pi over 6 to get 25. And I added another 12 to 17 to get 29. And I think this should be enough. I'm going to multiply everything through by 1/4. I'm going to shrink all these values down. And I get pi over 24, 5 pi over 24, 13 pi over 24, 17 pi over 24, 25 pi over 24. I know that I've gone far enough if I can see my fraction getting past my endpoint. So once my numerator is greater than my denominator, I know I've reached higher than pi. And it's nice to know that I've gone further because then I've ensured that I didn't accidentally miss something. So I know everything before 25 pi over 4 is all the solutions that I need. As far as trig identity goes, I would say the only one you have to worry about knowing is this basic one here. I would say don't worry about double angle identity, don't worry about half angle identity. And also, if you know this one, you also know two more, because if I divide by sine squared, I can create another version of it, which is 1 plus cotangent squared equals cosecant squared. And if I divide everything by cosine squared, I'll get tangent squared plus 1 equals secant squared. So I would say don't even worry about memorizing these two. Just know this one, and you can just arrive at these two just by dividing by either sine squared or cosine squared. Okay, so yeah, so the trig that you went through last year, we're just going to have to worry about just a really select portion from trig. Okay, what else? Any other questions? Yeah, the biggest thing is just knowing your unit circle well. I think that's the biggest need that we have for this course, for trig wise, in terms of information coming up to calculus. Just know your unit circle well. All right. Today we're going to cover page 15 through 18. And I think I just plan on going through as many types of problems. So I may be jumping around between page 15 and 18. And then whatever we don't finish will just be your homework to do over the weekend. Okay. All right. So let's see if I can just do one of each type so we can do something from every page. All right. So page 15. Number 6, find the equation of the line in slope-intercept form, passing through the following points. I say slope-intercept form here, but I think point-slope form is fine. I think that's what I prefer anyways. So point-slope form, let's do it that way. Again, if you write your equation, your linear equation in a different form than point-slope form, that's also fine. You won't get points taken off. It's just point-slope form, I think, is the more efficient equation to get to. So if I want to find an equation of a line through 2 points, all I need is a slope, and I can just choose either point. So to find slope, I'm just going to do change in y over change in x. And then I can choose either point to plug into point-slope form. Okay, so find slope, change in y over the change in x. You can choose either point to put into point-slope form. I'm just going to choose the first one I see. So this is fine. You can also write it this way if you want to choose the other point. All right, easy enough, right? So I'll skip B and C. Those are just following the same pattern as A. Let's look at number 7. Write the equation of the line through the given point that is parallel to the line, and then separately also write an equation that's normal to the line. So normal means perpendicular. So the only thing that we care about from the line that's given to us is we just care about getting the slope. After we get the slope of that line, we don't care about this equation anymore. Okay. So an easy way to get to the slope of a line is get it into slope-intercept form. So I'm going to just rewrite this equation. I get y is equal to negative 1x plus 4. What's the slope of this line? Negative 1. So for part A, I'm going to say m sub 1 is equal to negative 1 because that's the slope that is parallel. Parallel means same slope. So I want this slope going through this point. Part B, I want my equation to go through this point, but now I want something that is perpendicular to the slope. How do we find perpendicular slope? Yeah. Yeah. Reciprocal, right? It's obviously reciprocal. So we got to do 2 things here. You got to change the sign, and you have to get the numerator denominator to swap, right? Your reciprocal. So if I were to take the reciprocal of negative 1, it's still negative 1, but I got to change the sign. So my new slope is 1. So I'm going to use this slope and this point. Yeah, try part B. I just want to see that you guys can go through these steps here. So try part B. So rewrite your equation enough for you to be able to pull the slope. I'm sorry.
You can't have it too wide.
Yeah, I would solve for y, so I would divide by 2 to get that y by itself. Otherwise, you're not able to get a good read on that slope. Okay, any issues with rewriting the equation, pulling the slope to be -5/2, and including that slope and the point for your equation? What about part B? What's perpendicular to -5/2? Good, 2/5. Flip the fraction and change the sign. Let's do part C. Sometimes the easiest equations, the easiest scenarios can throw us off. So we don't, that we follow different sets of rules if you're just dealing with horizontal and vertical lines. So I think with this type of problem, I think it's easiest to just sketch the graph out and then just visually see, okay, what's perpendicular, what's parallel. So let's see what this graph looks like here. What does y equals -2 look like?
Crazy.
Horizontal line, right? So here's the line. -3, -4 is over here. -3, -4. So I want a line that goes through this point that is parallel to this line. So what would that look like? It's the horizontal line, right? And this, we don't have to plug into any equation. We can just read this off the graph here. That's y equals -4. That's part A. That will be the equation of my line that's parallel to this line. Okay. What would the line look like if it's perpendicular to this and goes through this point? Vertical line, right? It will be this line right here. And that's just x equals -2. X equals -3, yeah. So if you're dealing with horizontal vertical lines, just draw it out. It doesn't quite work with the formulas that we did. Number 8. Find the equation of the line containing 4, -2, and parallel to the line containing -4, 1, and 2, 3. So let's find the slope. And then once we find the slope, we're going to keep that slope and then put the point slope form with the 4, -2. So all we care from these 2 points is just the slope. It says general form, but let's just do everything in point slope form. All right, number 9. Find K if the two lines are, for one scenario, parallel, and the second scenario is where they're perpendicular. Don't worry about that K for now. Get both of these into slope-intercept form so we can pull the slope. So let's find what the slopes are for both these lines, and then we can worry about the next step later on. So I'm just trying to solve for y for both equations. And all I care about is the slope from both those lines. So the slope of my first line is 3/5, and the slope of my second line is -2/k. Any questions there? So if I'm going to have a parallel slope between these two lines, then these slopes have to be what? The same. Right? You just set these equal to each other and just solve for k. Just cross multiply and solve for k. Okay, if we want to create a scenario where these two slopes are perpendicular to each other, what can we do? Yeah, make one of these opposite reciprocal. So you can either flip this, change the sign, or flip this, change the sign. It doesn't matter. Just make sure you don't do it to both, right? You just choose one of them and you flip it. So, and change the sign. So I'm going to change the second one here. That's part B. All right, 16. So when we condense, that means we're trying to get everything down to one log expression. Let me write out the 3 properties. So you got the product property, you have the quotient property, and then you have the power property. So when you condense, you're basically trying to get everything on the right side back in terms of the left side. You're just trying to get it down to one singular log expression. So when you're condensing, I think the first thing to do is try to put all the coefficients up as exponents first. So I'm going to put that 5 up above the x as my first step. Now I can use the product property to merge the sum into a product there. Okay, try part B. Okay, any questions with B? When there are multiple, more than 2 terms added and subtracted, it may feel more complicated, but let me talk about a bit of a shortcut where you don't have to worry about, oh, wait, is this going to be the sum and then the difference? And then, so if I have, let's say, let me do an example here. If I have natural log of A plus natural log of B minus natural log of C minus natural log of D, what you can do is just look at the signs. Okay, you know that when you condense, everything is going to fall under one fraction. And I think the easy way to go about doing this is whatever log is part of a positive term, it goes in the numerator. Whatever log is part of a denominator, it's going to go in the denominator. Oh, sorry, has a negative coefficient, it's going to end up in the denominator. So positives in the numerator, negatives in the denominator. So if you think about it that way, then it's easy to place the pieces together. Okay. So for part C, I would start off with the coefficients, push the coefficients up as exponents. And then depending on the sign, you can place each of those terms either in the numerator or the denominator of your natural log. Anybody have any questions? All right, try part D. when you're expanding, you're going the other direction. So when you're expanding, all the numerators you're putting as plus, and then all the denominators, you're putting a negative sign in front of it. So imagine if you're starting here, this will be natural log of 2 plus natural log of x to the 4th minus natural log of 8 minus natural log of y cubed. And then once you've expanded it out, then you're going to push the exponents back down as coefficients.
Is it okay to have the square root on the bottom?
That's fine. Yeah. Oh, yeah. I also want to point out in this course, it doesn't matter if you don't rationalize the denominator, you won't get points taken off. So in this course, you don't have to worry about rationalizing the denominator. The only time you may have to do it is if for some reason on multiple choice AP exam, the answer choice has a rationalized form, then you got to get your version to look like their version. But you're never going to get points taken off or not rationalizing the denominator. Okay, so part A. Sorry, that's a log base 7. That's kind of hard to see there. Log base 7. Okay, try B, C, and D.
Could vary for those, right?
I'm sorry.
For those answers could vary, right?
The order may vary, but all the terms should end up looking the same. Yeah. Mhm.
For C, what's the number before root A?
Sorry, it's a fourth root of A. Yeah, sorry. And then for part D, once you get to that first step, that's good enough. You don't have to go any further. And also, we gotta be careful, right? If I have natural log of A plus B, I can't distribute that natural log through. This is pretty much stuck. So when you get to part D and you go through that initial expansion, you can stop after that first step.
You don't even have to do the other 2 steps.
No, this is fine. This is sufficient. Okay, any questions? Okay, we should be able to get through most, if not all, the homework by the end of class. But so for next 10 minutes, see if we can make progress on page 17 and 18, and then I have the key attached on page 19, 20, so you can check your progress. And I'll walk around, see if you're stuck on anything, if you have any questions. Have you guys work? For the next 10 minutes.
What she's gonna do.
Let me just show you real quick. This is similar to example 6. Just want to kind of walk through it since we've done something maybe not quite exactly like this. So it says find f of x plus h minus f of x all over h. We're basically wanting to get this out of function notation and into something in terms of a function. Whenever you see this, right now we don't know what this means. We're just making a great substitution. When we get to unit 2, we're going to talk about what this represents. But what can I replace f of x with? Or what's equivalent to f of x? 4x squared minus x, right? So f of x is my function, so I'm just going to make a substitution there. Okay. But I think the potential trouble is trying to figure out, wait, what can I replace f of x plus h with? And this is where we have to go through this method of replacing every x we see with x plus h. So if I want to build that f of x plus h, I'm going to have to replace every x in my function. So if I force a parentheses wherever the x is, then it'll allow me to build my f of x plus h. So now I can just replace every open parentheses with x plus h. And now this piece can replace that piece. So now if I get this out of function notation, replace this with what I built. And replace f of x with my original function. And put it all over. And the rest of it is just expanding, cleaning up, combining my terms. So I think the hardest part with getting to the next step is just trying to find a suitable replacement for f of x plus h. And the way you do that is take every x from the original function, remove the x, and put in the x plus h where the x was. So this is just an example that's similar to example 6, so that when you get to it, you can do something, you can follow the step.